Okay, so let's continue our section 2.5 notes. We are still looking at implicit differentiation. And so this first example, now that we know how to do implicit differentiation, we are going to be looking at a couple different examples and ways that we can use that. So this says, find the slope of the curve at the point 1, 2. And our equation is 6y cubed minus 2y squared equals x to the fifth plus 2x cubed. So slope of the curve, remember that means we are taking a derivative. Okay, at the point means we need to plug that in eventually. And what we're going to do to take the derivative of this, since we have x and y's, they're not easily solved for. We can't get x alone or y alone very easily. This involves implicit differentiation. Implicit differentiation means every time we take the derivative of y, we have to make sure that we write a dy dx. For the derivative of x, that's just dx dx. So technically, you do not have to write this every time because it's just going to turn into a times 1. Okay, so when we do this problem, we'll take the derivative of 6y cubed, so we get 18y squared. We took the derivative of y, so we have a dy dx. And then power rule again, so minus 4y dy dx equals, on this side we have x's, so we have 5x to the fourth. Dx dx is just times 1, so we don't need to write it every time. Can shorten our process a little bit. Then we take the derivative again, and we get 6x squared dx dx, which we don't need to write. So what we need to do is solve for dy dx. Right now, all of our dy dx terms are on one side. Non-dy dx terms are on the other. So all we need to do is factor out dy dx. Here, so we have dy dx. When we take it out of the first term, we have 18y squared. Take it out of the second term, we have 4y equals, we have 5x to the fourth plus 6x squared. And then the last thing to do, right now this is times, so I need to divide both sides by 18y squared minus 4y. So 18y squared minus 4y. So dy dx, our derivative, is 5x to the fourth plus 6x squared all over 18y squared minus 4y. Whew. Okay, so that's our derivative, but remember it says at the point, so we need to plug that in. So when we have a point, we have the point 1, 2. So our x value is 1 and our y value is 2, and that's what we're going to plug in. So now dy dx is going to equal 5 times 1 to the fourth plus 6 times 1 squared over 18 times 2 squared minus 4 times 2. And then when I simplify this, on the top I have 5 times 1 is just 5, 6 times 1 is just 6. On the bottom, we end up having 4 times 18. I'll go ahead and let you know that's 72. 4 times 2, so we have minus 8. So on the top we have 11, on the bottom we have 64. So that's our answer. Our slope at this point is 11 over 64. Let's look at the next one. The next example says find the equation of the tangent line at the point 2, 1. Okay, be careful when you read instructions. Equation of the tangent line. Equation of the tangent line means we are writing an equation in the end with y minus y1 times m times x minus x1. So we have to get all of these. They already gave us our x value. They gave us our y value. So really it's m that we're looking for, and m comes from the derivative. So we have to take the derivative of this. We're using implicit differentiation again. So we have 9 x squared, x's, we don't have to write anything after, minus 8y. We took the derivative of y, so we need a dy dx. Derivative of y, just y, is 1, but we need to make sure we have a dy dx there because we did take a derivative. Make sure that you don't drop down the 9. We are still taking the derivative of the 9. So if you need to go back to writing d over dx on each side first, you can. That is not a step that you must show. Okay, so from here, we need to solve for dy dx. The only thing that doesn't have dy dx is 9x squared, so we're going to move that over to the other side, which means we leave negative 8y dy dx plus 1 dy dx equals, we have negative 9x squared. Factor out dy dx, and we have negative 8y plus 1 and negative 9x squared left over. So what we need to do is divide both sides by negative 8y plus 1 and negative 8y plus 1. So dy dx is negative 9x squared all over negative 8y plus 1. Now be careful here because you might be tempted to cancel out these two negatives, but 8y is not the only thing on the bottom. We have a plus 1. So unless we can cancel a negative with that one as well, we can't cancel the negatives out. So they are going to stay. Okay, remember the point of this is getting our slope. So this right here is going to be our slope equation. And what we're doing is we're finding our slope at, they gave us the point 2, 1. So we are going to plug that into our equation. So we'll have negative 9 times 2 squared, because 2 is our x value, so we're going to substitute that in for x. Then we have negative 8 times 1, because 1 is our y value. On the top, we get negative 9 times 4, all over negative 8 plus 1. So we have negative 36 over negative 8 plus 1 is negative 7. Now I have one term on the top, one term on the bottom. Two negatives do make a positive. So this is 36 over 7. This is my slope. Remember, to answer this question, we had to make an equation. So our equation, y minus y1 equals m times x minus x1. We have to fill in these 3 points. Well, 2 of them they gave us. They gave us the point 2, 1. So 2 is the x value, so it goes over with the x. 1 is our y value, so that goes here. And then our m comes from our derivative, which is 36 over 7. And that's our equation. We have written the equation of a tangent line. Okay, so let's look at our next example. A little bit of a different problem. Okay, this example looks a little bit different than what we've seen before, so carefully read the instructions. It says find equations for the tangent line and the normal line to the tangent line at the point. Okay, so our normal line is perpendicular to the tangent line. So what that means is they told us that there was a circle. They said this equation represented a circle. It's not something that you need to know, okay? We have a tangent line touches the circle at one point. This is our tangent line. Perpendicular means they make a 90-degree angle. This would be our normal line. So it sounds like, oh my gosh, so much more work, but it's actually not, because what we do is we take the tangent and we just flip the slope and make it negative, and that's the normal line. Okay, so it's actually just like writing the equation for the tangent line. So, equation for the tangent line, eventually we are going to be writing y minus y1 equals m times x minus x1. Okay, so first, they gave us, what's nice, we have an x value and a y value, so they gave us y1 and x1. But remember, m comes from taking the derivative and we plug in the numbers. So this is always going to be a number, not an equation. So we have to take the derivative first. X and y are together, so we're going to do one at a time. The derivative, d over dx, of x squared plus y squared equals 36. So we have to take the derivative of all these things. The derivative of x squared is 2x. You can write dx. If that helps you remember to write the dy dx, that's fine, but you do not have to write it. Plus 2y. We took the derivative of y, so we need a dy dx. Then the derivative of 36 is 0. And then we need to solve for dy dx. So I'm going to subtract 2x from both sides. Whoops. This should just be a 2y. 2y dy dx equals negative 2x. Divide both sides by negative 2y. That's just a 2y. So when I get my answer, I have dy dx equals, these 2's can cancel, so it's really just negative x over y. And this, remember, this is how I find my slope. So they said to find the slope at the point 5 square root of 11. So to get our tangent line, our slope is just what we plug into our derivative. So that's going to be just m. So m is negative x over y. So x is 5, so we're going to have negative 5 over y. Y is the square root of 11. This is our tangent slope. Okay, so tangent is just what we would normally get anyways. Your normal slope is perpendicular. So I always put that, that's our symbol for perpendicular. Perpendicular is a long word. I don't really want to write it out. So that's why we use the symbol. Okay. To get a perpendicular slope, what you do is you take your slope. So slope is rise over run. If this is your normal and your regular, if you wanted to get the perpendicular one, what you would do is you would flip it and change the sign. So then it would be run over rise, and you would change the sign. So in this case, if we're looking at our normal slope, we take our tangent slope, which is negative 5 over square root of 11. So we flip it. Square root of 11 is on top. Negative 5 is on the bottom. And then we change the sign so it becomes positive. So that's our normal slope. That's all we do. There's no more derivative. It's just taking the tangent slope that we had to find anyways for the tangent line and flipping it and changing the sign. Okay, so that's what normal means. So if we see normal, we know we're doing the same thing as the tangent. We just got to flip the slope a little bit. So remember, if we go back up to the problem, they said they wanted equations. So that means we do the y equals, or y minus y1. So for the tangent line, y minus y1 equals m times x minus x1. Well, the point is 5 for x, so that goes with the x. Square root of 11 for y, so that goes there. And our slope, we just found here. So we get negative 5 over square root of 11. There's our equation for the tangent line. Normal line is very, very similar. We're still using y minus y1 equals m times x minus x1. We're using the same point, so it's at the same point. So our x1 and y1 have not changed. Those are the same. The only thing that changes for a normal line is the slope. So now it's positive, and it's square root of 11 over 5. And that's it for our normal line. You have made your normal line. Okay? So it's not that much more. It's just one little rule that you have to remember, that they're perpendicular, and to get a perpendicular slope, you flip the slope and change the sign. Okay? 2 steps for that. The last example, in the end of these notes, is again a little bit of a different flip on, we have to use implicit differentiation, but we're finding something that's a little bit different. So it says find the points. Okay, so this time it's points, no equation. We do not need y minus y1 equals x, m times, x minus x1, all that kind of stuff. It says find the points at which the graph of the equation has a vertical or a horizontal tangent line. Okay, tangent line, all that means is I'm taking the derivative, which we pretty much know anyways, because this is a calculus problem, not just an algebra problem. So tangent line means derivative. Vertical, I'm going to move the equation down a little bit because we don't need that yet. Vertical, right? A vertical line is up and down. So in order to find a vertical tangent line, that has to do with our slope. A vertical, the slope is undefined. So the 0 is on the bottom. Okay? Like if you wanted to walk on this street, and this street was straight up and down, you would not be able to walk on it. It is an undefined thing. That would not happen. You would just fall straight down and injure yourself. Okay? So a vertical line is straight up and down, and our slope is whatever 0 is on the bottom. We don't care about the top. Okay? The opposite, we have horizontal, which we also have to find, has to do with our slope. So again, that's just talking about derivative. And it's the opposite. It's when 0 is on the top. So we actually have a 0 slope, right? Our horizontal lines are side to side. This is something, there would be no incline. You are not getting a workout. Like the floor in the classroom is completely horizontal. It is not on a hill, okay? Horizontal is completely flat. Horizontal lines have no slope, okay? No tilt at all. So we need to find these two things. In order to find our tangent lines, if they're vertical or horizontal, we need to find the slope. Slope of the tangent line, derivative. So we need to take the derivative of this equation. So we're taking the derivative of 4x squared plus y squared minus 8x plus 4y plus 4. Okay? This is pretty much as long as it gets. But we don't have any product rules in this problem, which is nice. So the derivative of 4x squared is 8x. I don't need to write dx. Plus 2y, I do need a dy dx. Minus 8, that was an x, so I don't need to write anything after it. Plus 4, that was a y that I took a derivative of, so I do need a dy dx. Derivative of just 4 is 0 equals, derivative of 0 is 0. Okay, if you have any questions, please pause the video and ask me, or Miss Delmalva if she's here. So our next step is to combine things that we can combine and move everything, just keep things with dy dx and move everything else. So I'm going to subtract 8x from both sides. I'm going to add 8, 0, I don't have to worry about. So when I do this, I have 2y dy dx plus 4 dy dx equals, and I have negative 8x plus 8, because it was just 0 over there, so there was nothing to add those to. So we need to factor out a dy dx. So we have 2y plus 4 equals negative 8x plus 8. So dy dx equals negative 8x plus 8 all over 2y plus 4. If you wanted to, you could simplify this. Every single term is even, so you can divide 2 out of everything. So it could be negative 4x plus, what? 4. Dividing 2 out of everything because they all have 2 in common. 2y divided by 2, we just have y. 4 divided by 2 is 2. Okay. You don't have to simplify, but you can since they all have a 2. So remember, what we're looking for is we are looking for a vertical tangent line and a horizontal tangent line. Okay. So if we have the slope, a vertical tangent line is when the slope has a 0 on the bottom. So this is a number over 0. Well, our derivative is our slope. So what we do is we set that equal. We have negative 4x plus 4 over y plus 2. Okay. On the top, it's just a number. We don't care about the number. What would make this slope vertical is if the bottom was equal to 0. So we make that equation. 0 equals y plus 2. So y equals negative 2. Just subtract 2 to the other side, and you get y equals negative 2. Okay. And then they ask for points. So this is where our computations get a little bit long, but you have plenty of notebook paper. It's fine. You're going to be fine. We need a point or points. So to get points, we have a y value. So we could make a point with a y value, but we don't have an x value. So what we have to do is use the original equation to get the other one, to get the points. Okay, so our original equation, I'm just going to copy it down here because I'm on a computer. So we can bring that down. Our original equation is 4x squared plus y squared minus 8x plus 4y plus 4 equals 0. Okay, so what we did is we have a y equals negative 2. So where y is, we're going to plug in a negative 2. And we're going to get an x value or multiple x values. So we still have 4x squared plus, we plug in negative 2 for y because this is a y value. We leave the x plus 4 times negative 2 plus 4 equals 0. So we have 4x squared minus 4, well, plus 4, because negative 2 squared is positive 4, minus 8x minus 8 plus 4 equals 0. Well, these two terms have x's, so they're going to stay where they are. But these are all numbers. Plus 4 minus 8 plus 4. Well, that's 8 minus 8. All those are gone. So what we have is 4x squared minus 8x equals 0. In order to solve this, we need x equals a number, so we have to factor. In this case, we need to factor out what they have in common. They have a common 4. You can divide out a 4, and you can also divide out an x. So in the first one, we have x left over. In the second one, we have, if we take out the x is gone. 8 divided by 4 is 2, equals 0. So each of these we set equal to 0, and it'll give us 2 answers. Divide by 4, 0 divided by 4 is just 0. Add 2, so 2. So I have 2 x values, 0 and 2. So when I get my points, I use my y value. So this is going to give me 2 points. The y value we know will be negative 2, because that's what we found in the first place. That's what started this whole shebang. Okay. Then our x values, we have a 0 and a 2. So these two told me I was going to have 2 points. These are the 2 points. Those are the 2 points where I have a vertical tangent. Okay. Horizontal is exactly the same. So pay attention to these steps and make sure that you see what's happening. Okay. So for horizontal, it's the opposite of vertical. Instead of having 0 on the bottom, it's when we have 0 on the top. So if we set that equal to our equation, then we have negative 4x plus 4 over y plus 2. But we only care about the top because the bottom can be whatever number that it wants to be. It doesn't matter to us. So right now we only care about 0 equals negative 4x plus 4. And then to solve this, we subtract 4. So we have negative 4 equals negative 4x. So x is positive 1 because we divide this negative 4. Negative 4 divided by negative 4 is positive 1. So again, we have to use the original to get our points. Now we have an x value. So that means when we plug this in, we are using our original equation, okay, and we are plugging into the x's, which are here and here. What's getting plugged in is the number 1. So we have 4 times 1 squared plus y squared. We don't have a y to plug in this time. Minus 8 times 1 plus 4y plus 4 equals 0. So I have 4 plus y squared minus 8 plus 4y plus 4. Ooh, look what happens again. Positive 4, negative 8, positive 4. Those are gone. 4 minus 8 is negative 4, plus 4 is 0, so those are canceled. So now we have y squared plus 4y equals 0. So again, we're going to factor out what they have in common. In this case, these two things have a y in common. So when we factor it out, we have y plus 4 equals 0. Each of these will give me a value. I set outside equal to 0, inside equal to 0. This one's already equal. I don't have to solve that one. Subtract the 4 on this one. Negative 4. So again, I'm getting 2 points. A y value is 0. Our other y value is negative 4. Well, what's our x value? Our x value is up here. It's 1. Okay, so these two are the points where the line is horizontal. I know it's a lot of steps to follow, but you don't have that much on your homework, okay? You just need to know the process so that you can find this on your own, okay? I know that it gets long. If these problems get long, then you know that you're doing it right, okay? So that's it. And this concludes the notes for section 2.5. We are done with section 2.5. We will spend time in class tomorrow making sure that we can solve the problems. We'll finish the homework, have a little bit more practice. Okay?